evaluate the integral sine cubed x dx. So you know you cannot integrate anything raised to a power. So you use the Moivre's theorem to expand sine cubed x, isn't it? So from the Moivre's theorem, what do we know? We know that if you have 2 cos n theta, that is the same as Zn plus 1 over Zn, isn't it? Then we also know from the Moivre's theorem, if you have 2j sine n theta, that is the same as Zn minus 1 over Zn, isn't it? So it means when n is 1, because we want sine, we want the second part, isn't it? When n is equals to 1, what does it imply? It means we have 2j sine theta. In this case, we are using x. So we can say, instead of theta, we can just deal with x, isn't it? Instead of theta, our angle is? Are we together? So when n is 1, it means we have 2j sine x is equals to z minus 1 over, because where there is n, you put 1. Senor? So we remain with the 2j sine x to be equals to z minus 1 over z. Are you seeing that? What do we have here? Sine cube. So sine cube is the same as what? It's the same as sine x raised to power. So it means here we have, this is now what you go and put. You now have your 2j sine x to be equals to z minus 1 over z. So which power do we want? We want sine to be raised to power 3. Are you seeing the scenario? So if you want sine to be raised to power 3, meaning you raise both sides of the equation to power 3. That is when you'll be able to get sine raised to power 3. Are you seeing? Are we together? You raise both sides of the equation to power? Yeah, so from here, 2 raised to power 3 is what? Is 8, isn't it? Yes. Senor? Then j raised to power 3 is negative. You just use calculator, you don't struggle. J in the calculator is I. So you just put I raised to power 3, then the calculator will give the answer after setting the calculator to complex. Is that okay? Set the calculator to complex, then you just put I, which is the same as j, isn't it? Raised to power 3 gives you negative j. You don't strain or struggle. Is that okay? Are we together? So from there, sine x raised to power 3, you get sine cubed x, isn't it? Are we together? Not sine 3x, sine cubed x to be equals to, what do you do here? Binomial expansion, isn't it? So binomial expansion, when the power is 3, it means we have 4 terms, isn't it? When the power is 3, we have 4. So that is the first term, plus the second term, plus the third term, plus the fourth term. So what are the coefficients of a binomial when the power is 3? When the power is 3, what are the coefficients? 1, 3, 3, 1, isn't it? Senor? Then you start here, z, the first bracket is for z, isn't it? So we have z, 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 z. The second bracket is negative 1 over z, isn't it? Negative 1 over negative 1 over, negative 1 over z, negative 1 over z. Then, one power is ascending, one power is descending, isn't it? Which powers should descend? Now, you need to select. Here we have negative 1 over z, so meaning this is the power which should ascend, so that here becomes 1. Because anything raised to power 0 is? So that you start with z instead of starting with negative 1 over z or something. Are you seeing that? Are we together? So you let negative 1 over z to have the ascending powers, that is 0, 1, 2, 3. So that anything raised to power 0, this one is going to go to 1 to make your work look neat, but you can start with anything, isn't it? Yes. Are we together? Yes. So this is ascending, it means this other one is descending. Yes. So this is power 3, 2, 1, 0. Then we know anything raised to power 0 is 1. So this is 1, this one is raised to power 0 is 1. Are you seeing that? Then what do? The ones with the same power will always have the same coefficients. Are you seeing the scenario with the expanding binomial of this trigonometric function? The ones with the same power will always have the same coefficient, and the one which does not, which stand on its own, will always be the constant term. Are you seeing the scenario? So here we have power 3. It means the coefficient of this power 3 must be the same as the coefficient of the power 3. So you join them together. Are you seeing that? Yes. So there we now have the coefficient there is 1, the coefficient there is 1. So if you join them, 1 is outside. Here we have z raised to power 3. Then here we have Negative raised to power 3 is negative, isn't it? So it is minus 1 over z raised to power 3. Because this is negative 1 over z raised to power 3. If you join them, because they share the same coefficient 1. Are you seeing? The coefficient of this is 1, the coefficient of that is 1. So you join them together by factorizing out the common coefficient outside.
Yes.
Good. So that one is equals to, is this one captured? Good. Then, these ones are having the same coefficients, meaning you join them together, isn't it? So if you put 3 outside, remember, this is negative. So negative raised to power 1 is negative. Then, negative raised to power 2 is positive. Good. So what do? You factorize negative outside, isn't it? You factorize negative because you know from here, you either have positive in the middle or negative in the middle. We don't have negative starting. So if you want negative, you don't have negative starting. So you factorize negative outside, isn't it? So if you remove negative 3 outside, what do you get? Z squared divided by z, so you remain with z. Are you seeing? So it means there we remain with negative 3z. So negative 3 is outside, you put z inside. Then here, negative squared is positive. This is 1 over z squared. So z divided by z squared, it is 1 over z. So you have positive 1 over z, so it will go back to negative 1 over z because negative takes you back to the positive. Are you seeing that? Look at this. What I'm trying to say, when you have cos this, there's only positive or negative sign between them, isn't it? Negative sign cannot start. Is that okay? So in this case, when you have negative starting for the whole part, the one which is the fraction is the one which comes second, isn't it? So the one which is not fraction is the one which comes first. So this one which comes first must only have a positive sign. Are you seeing that? So it means when it has a negative sign, you factorize that negative sign outside. Are you seeing that? So here we had negative 3z because z squared divided by z is negative z times 3 negative 3z. So the first part here we had negative 3z. Then the second part here we have z divided by z squared is positive 3 over z. But negative cannot start, so it means negative 3 we factorize outside. So if you remove negative 3 outside, here becomes negative. Because negative and negative, you go back to the positive sign which was there. Is that okay? Good. Then after doing that, what do? You substitute. What is z cubed minus 1 over z cubed? Remember, z cubed means this. Z raised to power n minus 1 over z raised to power n. What is the answer? Z raised to power n minus 1 over z raised to power n. So it is 2j sine nx. Yes. So what is our n? Our n is 3, meaning where there is n you put 3. So it means it is the same as 2j sine 3x. Are you seeing? It is the same as where there is n, you put 3. Where there is n, if you put 3, it means this one is going to be the same as 2j sine 3x. So it means the whole of this is the same as 2j sine 3x. Are we together there? Then look at this. Z minus 1 over z is the same as what? Where you have the negative, it means n is 1. Are you seeing? Z raised to power 1 minus 1 over z raised to power 1 is z minus 1 over z. Meaning where the z you put 1. Meaning it is the same as 2j sine x. Are you seeing the scenario? Yes. It is the same as 2j sine x. So you can see, this side of the equation we have negative 8j sine cube x. So what happens here? From there, what happens? See, from here you can see j is a common factor all through, isn't it? See, you get rid of the common factor on both sides of the equation, meaning you divide by j all through, isn't it? So what do you remain with? You remain with here negative 8. What do you have? Negative 8 sine cube x is equals to 2 minus that, isn't it? But what do we need? See, we need sine cubed x. If we need sine cubed x, what do we remove? We remove negative 8, isn't it? Meaning we divide both sides of the equation by negative 8. So at the end, what have we found? We found sine cubed x. So what is sine cubed x? Sine cubed x is the same as what? 2 over negative 8 is negative 1 over 4 sine 3x. Then negative 3 divided by negative 8 is plus 3 over 8 sine x dx. Have you seen that? Meaning where there is sine cubed x, you substitute with this value. Meaning you now gotten rid of the power because you cannot integrate a power. Have you seen the scenario? The task here is to get rid of the power because you cannot integrate a power. So from the Moivre's theorem, we say sine cubed x we found to be the same as negative 1 over 4 sine 3x plus 3 over 8 sine x. Negative 3 divided by negative. No. There's 2 here. This is 3 times 2, 6. Are you seeing that? 6 over 8 is the same as 3 over 4. 3 over 4, isn't it? Yes, because we have 2 goes here once, 2 goes here 4. Negative 3 divided by negative 4 is positive 3 over 4, isn't it? You don't forget, you'll be very keen, okay? Good. So from there, we can now do the integration. We can now integrate. So here, you just use it standard integration on the spot. So you get here negative 1 over 4 is a constant. If you integrate sine 3x, the derivative of the inner function must be a constant. Meaning if the inner function is 3x, isn't it? If you differentiate 3x, you get 3. You are done with that, isn't it? So what is the integral of sine 3x? If you integrate sine 3x, you get negative. Remember, if you differentiate sine, you get positive cos. Are you seeing? Meaning if you are integrating sine, you get negative cos, isn't it? So integrating sine 3x is the same as negative cos 3x. Then you divide by the derivative of the inner function. Are you seeing? Are we together? Good. Then it is plus, the constant here is 3 over 4. Then you go, if you integrate sine x, negative cos, isn't it? So you get negative cos x. Then divide by the derivative of the inner function. The inner function is x. If you differentiate x, you get 1. See there? Meaning the derivative of the inner function must be a constant because it is algebraic substitution which came up with that fact, isn't it? Yeah. Are we together? Yes. Good. Then at the end you have your arbitrary integration constant. Then after that, what do? So you simply simplify. Negative times negative is positive. 1 over 4 divided by 3. 1 over 12 cos 3x. Positive into negative is negative. Then 3 over 4 divided by 1 is just 3 over 4 cos x plus c. Then you completed the integration, isn't it?